This is a presentation of Chapter 4, Section 7 in the 8th grade workbook entitled The Real Numbers. So let's go ahead and take a look at the top part there. In 1 through 6, they're asking us to write the names that apply to each number. Now, so that means you need the list of names that you can be using there. And that list is in your textbook on page 195. The list begins with the concept of natural numbers. Natural numbers are the counting numbers, so starting at 1 and 2 and then 3 and on down the list we go. The next term there is whole numbers. Whole numbers are the same thing, but we add 0 to the mix. Then we get to the concept of integers. Integers are anything that shows up on the number line. Sometimes people say it's their counting numbers, the opposites, and 0, which is another good way to express that exact same notion. And then we get to the concept of rational numbers. Rational numbers are anything we can write as a fraction. And that whole group of things is all kind of in the same bubble. And then in a separate bubble, you've got the concept of irrational numbers. Irrational numbers are things that cannot be written as a fraction. For instance, if a decimal goes on forever and ever and doesn't have a pattern to it, it's going to be an irrational number. The square roots of negative numbers are considered irrational numbers. And perhaps the most famous irrational number is the number pi. Now, even though sometimes we estimate pi is 3.14, 3.14125, or whatever it happens to be, those are just approximations. Pi, in reality, is a number that does go on forever and ever without a pattern. So those are some irrational numbers. And again, comparatively, or at least seemingly in our minds, there would be a lot fewer irrational numbers. Again, that's just kind of the way mind thinks. Since numbers are infinite, really there's an infinite number of everything, but it would seem like that concept would be a smaller pool of numbers, at least maybe in some of our heads. So we take a look at number 1 with negative 7/8. Well, negative 7/8 is not one of the counting numbers, so it's not a natural number. A whole number would be the same thing but add 0, so it doesn't fit into that mix. An integer is going to show up on a number line, so this does not show up on a number line. A rational number is anything that can be written as a fraction. Since this is written as a fraction, that means the answer here is simply going to be rational. And since rational fits the billing, it can't then be irrational as well. So that's all we'll write for number 1, is that it is rational. All right, let's go ahead and take a look at number 5 then. Number 5 says this, negative 25. So if we go down our list of options here, the first option there on the list again was the concept of a natural number, so one of the counting numbers, 1, 2, 3. Well, that doesn't fit that list, so that's going to be out. The second option there then is the concept of a whole number, so that would be the same list but add 0. It doesn't fit onto that list either. Integers would be the next option. That's anything that shows up on a number line. Negative 25 is going to show up on an integer, on a number line, so it is an integer. Since it is an integer, it is also then going to have to be a rational number. Remember, a rational number is anything as you can write as a fraction. If we write negative 25 over 1, that is equal to negative 25. So that's why it fits the billing. And again, if it hits any one of those categories, you don't have to worry about irrational. The only time irrational is going to come into play is if it doesn't hit any of those 4 categories, the concept of natural, whole, integer, or rational, and then it would then have to be an irrational number. All right, let's go ahead and go down and take a look at the next section here. In the next section, the directions ask me to state if the number is rational, irrational, or not a real number. So remember, a number is rational if it can be written as a fraction, If it cannot be written as a fraction, it's then going to be a irrational number. And if it doesn't fit into any of those buildings, then it's going to be not a real number. And really, there's very few of those that we would have to worry about here. So we'll see that though in a moment. Number 7, the square root of 14. So the square root of 14 is 1. You're going to want to go ahead and plop into the calculator there to get an idea of what that's going to look like. Remember, either one of two things is going to happen here. Either that answer is going to work out to be something that is can be a decimal that repeats, or a decimal that does not repeat. And when we go on to that one, it is a decimal that does not repeat, 3.741657,387, because it's not repeating. There is no pattern. When there is no pattern, it can't be written as a fraction. If it can't be written as a fraction, it is irrational. Now, when we try the next one, the square root of negative 16, I would encourage you to put that in on a calculator there and see what happens. And what you want to do when you do that is put the negative 16 in parentheses, because that's going to show you what should be happening there. What you will get is some type of an error message. There is no such thing as the square root of a negative number. Because think about it, a square root is, when we go the opposite direction, what number I can multiply by itself to make a given number there. There is no number that I can multiply by itself to make negative 16. Some of you might be sitting there going, well, wait a minute, what about negative 4? Well, remember, negative times a negative makes a positive, not a negative. So there is nothing I can multiply by itself to make negative 16, so that means this one is not real. Now this is different than the question directly beneath it, number 12, because in number 12, notice where the negative is. The negative is out front of the problem there. It's in front of the square root. So what you're doing in number 12 is you're taking the square root of 81, 9, and then you're going to stick a negative on it, and that would be negative 9. If it worked out to be negative, which again we know it can't be, but if it was something that worked out to be negative and that had that negative in front, it would then make it positive. So since we know that that's going to be negative 9, and negative 9 can be written as a fraction, we've also now figured out that one, that that's rational. Okay, one more here. Number 9, 6.2 over 0. Well, we remember that dividing by 0 is something that is not allowed. Think about it. When we talked about this many times before, we can go with a simple fraction, 1 out of 2. 1 out of 2, when we think back to how we learned fractions in elementary school, means we had 2 pieces of pie and I ate 1 of them. So then if we think about it in 0 out of 2, that means I had 2 pieces of pie, but I didn't eat any of them. That's okay. But then if I try and flip it around, 2 over 0 would mean I ate 2 pieces of pie, but there weren't any to begin with. That obviously does not make any sense. So number 9 is also going to be not real. All right, let's go ahead and go down and take a look at the questions down here at the bottom, 15 through 20. In number 15, 16, and 17, they're asking you to find a real number between each pair of numbers. So really all they're saying is find something that's in between the two things they've given you there. What most of you are probably going to do in number 15, because since we have fractions, that would imply to do that you need common denominator, is you're probably going to just divide those out to make this much easier. 7 and 3/5, well, if you do 3 divided by 5, that's 0.6. So this is 7.6. And with 7 and 4/5, you're going to do 4 divided by 5, which is 0.8. That's 7.8. So I'd be looking for something between 7.6 and 7.8. And of course, most of you are going to say the easiest thing we can, which is 7.7. And you can use that same approach in helping you answer 16 and 17. Go to all decimals, find something that's in between. Life is very good. All right, Number 18, 19, and 20 are going to have you practicing with those definitions and those number types that we saw that we really went through earlier in the top set and then again in that middle set of questions there. We'll go ahead and take a look at 18. It's asking me to give an example of a rational number between the opposite of the square root of 4 and the square root of 4. Well, we know the square root of 4 part is going to equal 2. So really what they're asking me here is something between -2 and 2. So it's really a continuation of what we've just done there in 15, 16, and 17. And that's going to be, pick a number. I'm going to pick 0, the one that's right in between.